welcome to our third lesson as we look at two variable data sets. We're working with linear equations. You're going to basically feel like this is lessons on linear equations because we do need to understand how they work. We're going to be looking at data that shows up in what we call a scatter plot. We want to fit a line, make an estimate of the average of values. But in this case, we've got points that land on the line. Later when we do scatter plots, it gets a little different. So be thinking how we have this tool of relating linear relationships. One of the things I want to say is there are four types of relationships in math that we talk about, otherwise called models or representations. Sometimes we see the relationship in words, and we should be able to turn that into an equation. The equation could be graphed, and there could be a data table. So words, equations, graphs, and tables are all four ways of saying the same thing. So when you go through this information, be thinking, if I am solving a problem that's an equation from a graph, I might need to get the graph from the equation. Be ready to go back and forth on this. All right, so here we go. Slope-intercept form. I accidentally got into that in a previous lesson, and I hadn't quite taught it yet, but it should have been shown. It should have showed up last year when you dealt with linear equations. Y equals mx plus b. One of the things you want to think about is this y and this x, independent and dependent variables, but the m is the rate of change, often we call it the slope, and the b is the y-intercept. So it's a good name for it, slope-intercept. The slope and the y-intercept have to be in this equation and easy to read. That's what we like about it. The y-intercept then, if we're looking at a graph, we could say it's the value of y when x is 0. That's a good thing to remember. Anytime I get to my x-axis and find 0, I go up or down until I get to the graph. That would be my y-intercept, okay? The y value when the function crosses the y-axis. So the y value, it occurs at x is 0, and that number is 60 here. So these are both interchangeable, and this really works over when we look at this kind of stuff. The y value across from x equals 0 is another way of saying what the y-intercept is from a table. So if I see a table here with an x of 0, the y-coordinate across from it is the value of y when x is 0. That's the y-intercept also. So I'm going to, now that I see all the things that we talk about and how quickly things change, I'd ask you to really keep in mind what the changes are and where they're occurring and try to keep track of it. But don't get confused that we have 5 different things going on. It's all the same stuff. We just have different ways of saying it. So for instance, Emily starts with a bank account of $1,000. Well, that's pretty obvious. She starts at $1,000. And each month it changes by $150. Well, that means if X is my months, then if 0 months go by, I have a y-intercept as 1,000. But if 1 month goes by, I do 150 times 1, add it to my original amount. If 7 months go by, I can find the value in her bank account by doing 150 times 7 and then adding to 1,000. How much is in her bank account after 4 months? Well, I can do this. Y equals 150 times 4, and then plus the 1,000 she started with. And we can do that kind of quickly. 150 doubled is 3, so 300, that's $600. Plus the original 1,000, she has $1,600 in her account. And always be thinking how you can do the math correctly, but also give the context. Make sure you answer the question in the information that makes sense. This is $1,600. It's not just the number 1,600. There's meaning to it. I'm going to come down here. I need to find the M. So these are the things we're really after. The M and the B. The B is the easy thing to find here. And notice the Y and the X are always just part of my formula. And then I'm going to have 60, because that's where the line crosses the y-axis. And then it looks like it goes down from 54 down to 36. What is that? That 18? Yeah, that looks like negative 18. And it takes, oops, it takes 1 to 4, that takes 3. So we could say, and I could do the calculation here with all the numbers, right? 36 minus 54 over 4 minus 1. You'll notice that the top number is going to be negative the way I did it, but if you call this your second value, then the denominator would be negative, and you still get a negative 18 over 3. And 3 goes into 18 6 times, so I'm going to simplify that and just call it negative 6. All right, so what's the meaning? Might as well throw that in there. The temperature, temperatures at various altitudes, they vary by 6 degrees Fahrenheit per 1 mile of altitude. Okay, I'm not going to write all that out, but you want to think like that. Write an equation for this table. Okay, we have a constant change here of 2 and a constant change here of 10. So every 2 whatever x's are, I'm changing by 10 on the y. So my y depends on x by a factor of, in this case, 10 over 2, kind of a clumsy number. Let's simplify that. That means 5. So I have y equals 5x. Now, in the other ones, I found the y-intercept real quick. It's pretty easy to do. But in this case, I'm going to have to work backwards. So let's see here. In 2 changes of x, I added 10. So that must mean what happened up here? Well, that's got to be 10 bigger for those 2 changes going back. So we can say it must be 34. All right. Got a few problems here, and then we'll be done as far as like our classwork. Match each equation with the correct description. I suggest you read things carefully and thoroughly. I'm going to go a little bit quicker than I'm sure a student would, but I want to make sure you see this and watch the video again. Ask questions if you have them. Okay, so it says here, these are the balances. The balance of a bank account is going to be the starting value whenever you looked at it. And then this is the change in weeks. Every week you lose $32 because it's an overdraft fee. So anyway, when I look at my multiple choice answer here, I have a starting value of -5. This is the only one that has a -5 starting value. So this has to be our D. And this is a balance of -5. If you plugged in a 0 for x, you would have a starting value of -5. That's our y-intercept. And then a weekly overdraft fee actually takes money away from you. Okay, and that kind of makes sense. If we're already at -5, that means you took more money than you had with your bank, and that's called an overdraft. Reading this one, you have a $5 balance, so that should be this positive one. So this answer has to be C. And you're depositing. That means you're adding $32. So in week 0, my starting balance is $5, and then every week after that, you just multiply the number of weeks times the change and add it to your original amount. Looking again here, $32 balance. The balance is the starting value, so it's got to be A for this guy. And let's see. Oh, so this has a fee. That means we're losing money. So we're losing $5, even though we started with 32. And then finally, a negative starting value of 32 has to be this equation. And the equation shows it's increasing by 5. Notice the slopes there. Okay, write an equation in slope form for the following. You start with a pool that has 10 inches of water. It drains at a rate of 2 inches every hour. How long does it take until the pool is empty? Okay, well, my equation, y equals mx plus b. I need a starting amount and I need a change. So let's see here. Starts with 10, so I'm going to say a plus 10 out here. And then it drains at a rate of 2 inches every hour. So if I did 0 hours of changing, you're going to still have your 10, your original amount. But if I want this to be emptied, well, that means that if y is my inches of water, I'm going to go ahead and set my equation here equal to 0 and just solve for x. And x is going to be the time that it's been draining. This is the rate that it drains times how long it happens. So a two-step equation here, I'm going to get, I'll go over here. This will cancel out. I get 2x equals -10 divided by 2. I get x equals -5. That doesn't seem quite right. You know what you got to do? If this thing is draining, that means the slope is negative. So we got to put a negative there. Now I'm going to set it equal to 0, subtract 10, and I get negative 2x equals negative 10. That's kind of weird looking, but we divide by a negative, and we get x equals 5. So when I found a real world answer that didn't make sense, it caused me to look at my equation and find out I set it up wrong. So the question, how long does it take until the pool is empty? 5, and in this case, the units are hours. Swing down to this next one. You begin your hike at 1,500 feet. That sounds like I guess I'll start over here again. 1,500 starting value. And then each hour, descend 200. Descend, that's a negative 200. You're getting further down the mountain. How many feet above sea level are you after 4 hours? Well, this tells me where I'm at, my height, and this x is hours. So if I plug in 4 hours, that should be a 0. Negative 200 times 4 is negative 800. You take away 800 from 1,500, you get 700 feet. And I should really put units on this other one too. This was, oh, I had to get put over there, didn't I? Good enough. 700 feet. You begin constructing a wall at a height of 2 feet. So its starting value was 2 feet already. So there's a +2 out here. And each day you add 1 foot. So you're adding a positive 1 per 1 day. So 1x plus 2. How tall is it after a week? Well, a week is 7 days. So that tells me that tells me 1 times the number of days plus 2. 7 times 1 is 7, plus 2 is 9. After a week, you should have a 9-foot tall table, wall. All right, finally, concert hall charges $10 entrance fee plus $15 for each ticket. So even if I don't buy any tickets, theoretically, I'm going to pay $10. So my equation should be something with a plus 10 out here. And I increase my cost by buying 1, 2, 3, however many tickets. That changes 15. So if X is the number of tickets I buy, then 15 times X is how much I spend for all those tickets, whatever X ends up being. And then I have to add $10 for the processing fee or whatever that was. So purchasing 4 tickets tells me I have 4 $15 charges plus the original 10. That's going to be 60 plus 10. So this question is answered. How much does it cost to purchase 4 tickets? It costs $70. Has a partly what we call a variable cost as well as a fixed cost just for getting the opportunity to buy the tickets. All right, hopefully that goes well. We'll see you in class.